Hello everyone, welcome back to our channel. This is Mr. J here. Today we're going to do revision of vectors. So the focus of our session today is on what is a vector, representing vectors, inverse vectors, equal vectors, magnitude of a vector, and coordinates of a point, and position vectors. So here we have a grid map. And shown here in red is a hurricane. Now look at these rays. What do these rays indicate? So some of you would say the rays indicate direction and also distance. So here we have two vectors actually showing the pathway of a hurricane. It shows the direction and magnitude. You'll hear more about this as we proceed. So there are two important characteristics of vectors. One, it has magnitude, how long it is, and it has direction. Vectors are represented graphically by a directed line segment. So we have two figures here. The one on the left shows the direction and also the magnitude. And the one on the right shows how you can label our vector. So in this case, our vector is labeled AB with a ray above the AB. Notice that the starting point is at A, we call it the tail, right? And it goes to B. And we see the head of our vector is actually at B. Now you can use a common letter to also label this vector here, U, with a bar beneath it. Very important. So we want to look at vector notation now, students. So vector notation is this 2x1 matrix as shown here, where you have an x component and a y component. So our x component is that movement of our vector that is parallel to the x-axis. So if we consider the x-axis, the values on it, once we start moving to the right, then the values increase, and once we move to the left, the values decrease. So a right movement will be considered as positive and a left movement will be considered to be negative. Similarly, the y component, once you move, an upward movement will be considered positive and a downward movement will be considered negative. So how do we represent vectors as column vectors? So let's look to the left of our screen, and now we are looking at several vectors. We want to start with vector A, and we want to write it as a column vector. So we are going to start here at the tail of vector A, and we are going to move in the direction parallel to the x-axis, in the direction of the head. And so we'll make one movement there, and that is to the right, so that would be 1. And then to get to the head, we would move 2 units up, and so we're going up, so that would be a positive 2. So our column vector for vector A would be 1, 2. Now let us do one more. Let us do vector B. So let me change the color. So we start here at the tail of our vector and we move in the direction of the head. So we would go across 3 units to the left. So that would be -3. And then to get to the head, we go down 2 units. So that would be -2. So our column vector would be -3, -2. So I'm going to leave the rest for you to do. Pause the video while I put the answer on and try it on your own. So I want to bring our attention back to representing a vector. So here we have a vector AB, or we could say A. In various books, they represent vectors differently. So I just want us to be aware of the way they would represent the vectors. So there you go. You would have the vector AB with the ray above it. You would have vector AB, the capital letters, being bold. You'll also have the common letter being bold, or it can be simply represented as a column vector. So, and you have more ways of representing vectors. So the important idea is that you should know that you are working with a vector. So let us continue with the idea of representing our vectors. So how could we label this vector? So notice the direction. Direction is very important. So our tail is now at B and the head is at A. So our vector is labeled BA. Now that is very important that we get that. So let us put our vector on a grid and let's put the X component and the Y component. Are we able to write this as a column vector? So our column vector would be -3, -4. Okay, and this would be, our vector is actually going opposite to the one that was just shown. So I have a -A there. So let's us examine these two vectors, vector AB and vector CD. What can we observe about these two vectors? Take a moment. You are able to pause the video. So if you said that they are going in opposite direction, then you are correct. And the name that we give to these vectors are inverse vectors or negative vectors. Now they have the same magnitude, but their directions are opposite to each other. Very important. Now the question I want to ask, are they equal vectors? So take a moment, pause the video and tell us and think if they are equal vectors. Now they must have the same magnitude and direction to be equal vectors. So if you have that or you add that, you are correct. So we want to now look at how we find the magnitude of our vector here shown, vector AB. As we know, our column vector is 3, 4. And if we should add the X and Y components, we should draw that. We notice that we have a right angle triangle. Now, if we should consider our vector to actually be the hypotenuse, it's a line segment, line segment AB, and it to be the hypotenuse of our right angle triangle. How would we go about finding the length of AB? Now, just a point for you to note that the magnitude of a vector is shown by two vertical bars on either side of the vector, like what is shown here. So I would suppose that you would have said that the square of the hypotenuse is equal to the sum of the square of the other two sides. All right, so and we'll just solve for the hypotenuse AB. So we would have the all of that with a square root sign over the sum of the square of the other two sides. So we are, once we work that down, we'll get 5. So the question is, what is the theorem and general formula for finding the magnitude of a vector? Well, of course, many of you would say the Pythagorean theorem or Pythagoras' theorem, and that would be correct. All right, so we have our general formula being shown here. Okay, so let us consider coordinates. What if we are given coordinates, right? And we are asked to find the magnitude of our vector. So we could construct a right angle triangle. And you may ask, so did I get 3 or did I get 4? Simply, to get this horizontal distance, I would subtract 2 from 5. And to get this vertical distance, I would subtract 6 from 10. Okay, so I would suppose that you have something set up like this, where you would actually get the length of AB to be 5. Of course, this is the general formula for finding the magnitude of a vector, or we could have using the coordinates. A similar version. It's just a version of it to get to our same answer. So let us look at the coordinates of a point and a position vector. So here we have on the left side of our screen a Cartesian plane with several points, A through to F. And my question is, what is the relationship between coordinates of a point and a position vector of the same point? So let us look at 2 of the points that we have here. The coordinates of point F, what would that be? Well, that is -3, 6. What about the coordinate of point C? Well, that is 5, 1. And we want to look at the position vectors of these points. So our position vectors actually start at the origin of our Cartesian plane. So our position vectors are actually tied to the origin. So we have vector OF and we have vector OC. And if we look at the column vectors for OF, that's -3, 6. For OC is 5, 1. So what is special about the coordinates of a point and the x and y component of the position vector of the set point? So we should realize that the x coordinate and the y coordinate corresponds with the x and y components of the set point. And this is a very important concept that you'll be tested on your CSEC exam. So how do we find the column vector for vector FC? It is not shown here. So let us consider, let me put it there. Let us consider we are at point F and we want to get to C. But we are unable to travel along this path directly to C. So what I normally tell my student, consider it is a path or a road and you are to travel along this road, but you realize that it is blocked. How would you get from F to C? Well, they would normally tell me, I go from F and I can go to O, the origin, and from the O, the origin, to C. And that's how you would construct your formula. All right, so what we have here is vector FC is equal to vector FO plus OC. Now, as I said, that direction is very important. Notice that what we have here, we know OF, position vector OF, right? But we are going counter or in the opposite direction from F to C or from F to O. So that would be FO. All right, so what do we do? So we use up our idea of negative or inverse vectors where we have to multiply our vector or position vector OF by a -1. So our signs will change, and we'll go ahead and add them, and we would get 8, -5 for our answer. Now we can find FC graphically if you are ever given a graph in your CSEC examination, and in most cases you should be able to find our column vector graphically. So starting at F, we move horizontal to the x-axis in the direction of the head, and then we move to the head vertically horizontal to the y-axis. So you should get 8, -5. All right, thanks for joining us. Looking forward for you to watch our other videos on vectors and various other math topics.